Today's topic is alternating current. What is alternating current? We know already that one. The current whose magnitude changes continuously and direction changes periodically is called as alternating current. That means, I will write the definition. The current whose magnitude changes continuously. Whose magnitude changes, current value changes continuously. Changes continuously and direction changes periodically. And direction of current also changes. Direction changes periodically is called as alternating current. This is called as alternating current. If we draw the graph between the alternating current and voltage, we will get the graph like this. For example, we will take like this. This the time is on x-axis and the current or the voltage is taken on y-axis. If we draw the graph, we will get the graph like this. Let us see here. Like this. What happening here, the current value is increasing and become maximum. This we can take as the peak value of current. Next, current value decreases and becomes 0. This meaning is that the current is oppositely increases and become maximum. This is minus I naught. This is plus I naught. And oppositely current decreases and becomes 0. Like this, sometime current will flow in one direction, sometime current flow in another direction. This type of current, that current value continuously changes. Sometime positive current and sometime negative current. Current direction, sometime one side and sometime other side. This is the alternating current. And the source of AC we write here like this. Source of AC, alternating current source. We write, the symbol is like this. Okay, this is AC source. AC source symbol is this one. Here, this is the AC source. We cannot write this side plus, this side minus, because plus minus will be changes. When plus minus changes, then sometime current will go this side, sometime current will go this side, because plus minus are changing with periodically. Right? This is the AC source. But the DC source symbol already we know. The source of DC, right? The source of DC. The DC source symbol is what? We know already DC source symbol. Right? This is the DC source symbol. It has the fixed terminals, means direction does not changes and the current value also does not changes, but it does not have the fixed terminals, right? And now this is about alternating current. But here if you want, right, AC source voltage, what is the voltage of AC source? AC voltage means what? The voltage whose magnitude changes continuously and direction changes periodically is called as AC voltage. In our household purpose we are using the AC voltage. And now the voltage at any instant of time, how we will write? AC voltage or AC source voltage. AC source voltage we write like this. AC source voltage is varies with the time, that's why we can write it is the sinusoidally varies, that's why we write as V is equal to V naught sin omega t. This is equation 1. And AC current, if you want to write AC current, alternating current, okay, that we write as either I is equal to I naught sin omega t we write, or otherwise I is equal to, sometimes I is equal to we write as I naught sin omega t plus or minus phi also we write. This is equation 2. What is omega in this? Omega is the angular frequency. Angular frequency. Omega is the angular frequency of AC source, right, or AC current. And omega we write as the formula 2 pi by capital T. T is the time period, or we write 2 pi nu also, where nu is the frequency. T time period and nu frequency. Nu is the frequency. Okay, what is the phi here? Phi is the phase difference. The phase difference between the current and voltage. Voltage angle is omega t, current angle is omega t plus or minus phi. This angle difference is called as the phase difference. Phase difference between current and voltage. This also gives the angle between the voltage and current. This also gives, or we write angle between AC voltage and current. Okay, right. This is about alternating current introduction. Okay, now let us go for in alternating current. In our house or in industry, generally we will use the alternating current. This current value is varies, this voltage value is varies. Then how much voltage we will take? If you connect the AC ammeter, how much current it can measure? If you connect AC voltmeter, how much voltage it can measure? That I am going to discuss. I will try to find the average value of current in complete cycle. In one cycle, how much average value of current will be there? Okay, I am going to find out the average value of current or voltage in one complete cycle. Then how to find out the average value of current? There is one mathematics formula is there to find out the average value of a function. Okay, current at any instant of time, instantaneous current at any instant of time, there is a formula is there. Current at any instant of time, that is AC current, right? In an instant of time t, we write as I is equal to I naught sin omega t. The current is a function of time. Then I want the average value of current in one cycle. Average value of current in one complete cycle. In one complete cycle. What is complete cycle? Complete cycle means for one cycle the time taken is capital T seconds. That means the time range limits are 0 to T seconds. Then there is a formula is there for the average value of current. That is average value of current is equal to integration, the time to limits we have read. There is a mathematics formula is there to find out the average value of certain function. That is average value of certain function we write like this in certain interval of time, right? Integration 0 to some time t f of t dt by integration 0 to t dt. This is the formula to find out the average value of a function in certain time, right? Here average value of function f of t I want to find out. For that 0 to t integration f of t dt by 0 to t integration 0 to t dt we have to write. Here the time limits are 0 to t. I want to find out the average in one complete cycle. The for complete cycle time taken is time period, and function of time here average value of current is the function. That's why we write as I is I naught sin omega t, I dt we have to write by integration 0 to t, time limit is capital T, we write here like this, into dt we have to write. Okay, this is the thing. Then average value of current we write like this, that is here I naught we write outside, integration 0 to t sin omega t dt we write by integration dt is t we write here, but the limits are 0 to capital T, and then here we will get as I naught by this one is integration limits we have to substitute in place of small t capital T minus in place of 0 we have to write, then we will get capital T in the denominator, then integration 0 to capital T sin omega t dt we will get, sin omega t dt we will get. Okay, right, this t we write as limits in place of small t we write, or otherwise we write one more step, no problem, we go for that. I naught integration 0 to capital T sin omega t dt by In place of small t we write capital T, minus in place of small t we write 0. Limits we have to substitute. Then after that we have to write like this. Average value of current in one complete cycle is I naught by t integration 0 to capital T sin omega t dt we have to write. But in the mathematics, if you find out the sin omega t differentiation, okay, if you do the simplification, integration 0 to t sin omega t dt, we will get as 0. Okay, you remember directly PCB students, PCM students, you can do this one in your own, right? Average value of current we will get as I naught by t into 0. That means the average value of current is 0 we are getting, right? That means average value of current in one complete cycle, average value of current in one complete cycle, in one complete cycle is 0. Okay, similarly if you find out the average value of voltage also we will get the 0. Average value of AC voltage in one complete cycle is 0. That means average value of voltage is also 0. Why this is 0? Because in AC circuit we have how much current, positive current we have, that much negative current also there, right? You see here, this is 0 and this is capital T. Here in this how much positive current is there, that much negative current is there. That's why sum becomes 0. Then at that moment average also becomes 0 in complete cycle. In complete cycle means we have positive and negative, right? How much positive we have here, that much negative we have. That's why the average current we will get is 0. Average current we will get is 0 in one complete cycle. In half cycle if you will take, only one positives are there, then average you will not get the negative. Okay, this is how to find out the average value of current in complete cycle. Let us go for average value of current in half cycle, right? Here we are getting the average value of current as 0. That's why we cannot say that the 0 current is passing in your house, right? Then there is another method is there. I will try to find out the average value of current in half cycle. Take the screenshot and note every point. I am going to rub. Okay, let us find out the average value of current in half cycle. Previously we find out the average value of current in complete cycle. Then I am going to find out the average value of current in half cycle. Instantaneous current, right? AC current we write like this. AC current function we write as like this. That is I is equal to we write as I naught sin omega t we write. And average value of current in half cycle I want. Then further purpose, the current AC current is varies, that's why we are writing like this, where I naught is the maximum value of current, right? Average value of current in half cycle I want to find out. Then average value is equal, we have a formula in the mathematics already I said, that is average value of certain function we write like this, that is 0 to t in certain interval of time, right? 0 half cycle means 0 to limits are t by 2 half cycle. For complete cycle time period is t, half cycle t by 2. 0 to t f of t dt we write by integration 0 to t dt. This is the formula, mathematics formula to find out the average value. And here we write integration 0 to t. I we write as I naught, here function of time is current, average value of current I want to find out. That's why function of time we have to take current function. Current function is sin omega t dt. Okay, I is the I naught sin omega t dt we have to write by 0 to t. Limits we have to change, no? The limits are t by 2, 0 to t by 2 dt we have to write. And the next, here we have to find out the average value of current, that is I naught we have to write outside, integration 0 to t by 2 sin omega t dt we have to write by integration dt is t we have to write, integration dt is t. The limits are 0 to t by 2 we have to write. And here we will get I naught into integration 0 to t by 2 sin omega t dt by small t, limits we have to substitute in place of small t capital T, t by 2 minus 0, we will get as average value of current is 2 I naught by t into integration, this t by 2 become 2 I naught by t, integration 0 to t, t by 2 sin omega t dt we have to write. Okay, right. Now let us go for the next continuation. Average value of current is, we will get as 2 I naught by t into this one. You remember already I said that integration 0 to t sin omega t dt is 0, but integration t by 2, if the limits is there, limits are changed, then this value is t by pi is the value, its value. Okay, you substitute here t by pi, and then what you will get? You will get as average value of current is 2 I naught by pi. Okay, this is the formula for the average value of current in half cycle. Okay, and this is equation 1. If you want, you can do the integration also, there is no problem, right? And now average value of voltage, how to find out? Average value of voltage in half cycle, this is AC voltage. Average value of AC voltage in half cycle. Average value of AC voltage we write as 2 V naught by pi. This is the formula. What is I naught and V naught? I naught is the peak value of current. Peak means maximum. Peak value of current. What is V naught? Peak value of AC voltage. Okay, right. Average value of current or voltage is not equal to 0 in half cycle. If you want this derivation, I will do note, and I will give in the note. Okay, what is integration 0 to t by 2 sin omega t dt? There is a formula is there for the sin omega t differentiation integration. It is not required. If you want, you can, I will give. Integration sin omega t differentiation is, integration sin omega t is, there is a formula is there, that is cos omega t by omega. Integration sin is minus cos omega t by omega we will get. Okay, 0 to t by 2 is the limits. Here minus 1 by omega we write outside. We will get like this. Cos omega t we write as 2 pi by capital T into small t. The limits are 0 to t by 2. Now substitute the limits. Okay, just go for like this continuation. That is minus 1 by omega. Limits you substitute. Cos 2 pi by capital T into small t is t by 2. Upper limit you have to substitute. Minus we have to keep cos 2 by t into lower limit we have to substitute. Lower limit is 0. Then finally what you will get? Minus 1 by this omega we write as 2 pi by t. Omega formula 2 pi by t. 2 pi by t. T goes to numerator. T by 2 pi into, if you substitute this one, t cancel, 2 cancel, cos 180 we will get. Cos 180 value is minus 1. Minus here this is 0. Cos 0 value is 1. Finally we are getting the something minus 2. This we will get is minus t by, what you will get here, minus 2, minus plus, right? 2 cancel, then finally we will get the t by 2 pi. T by pi we will get. Bus. This is how to calculate it. It was very simple for the mathematics. Okay, and for the PCB students you can remember directly. If the 0 to t is there, then 0 you will get. If you 0 to t by 2 is there, then the t by pi. You can remember like that. Okay, right. this is about average value of current in half cycle. Take the screenshot and note it every point. Okay, now let us go for the next topic, that is RMS current. RMS current means root mean square current. Then actually if you find out the average value of current in AC, we are getting the 0. But that is not correct. Zero current we cannot say. That AC current is passes means then some current is passing. We have to say some current passes through the wire. Right? Now if you connect the AC ammeter to a wire, okay, it can measure the current. That current value equal to RMS current. RMS current means root mean square value of current. The heating effect of AC current, how much heat produces, that is equal to heating effect produced by RMS current. Heat produced, for example, this is a resistor, across this I current passes at any instant of time. For AC current formula is I naught sin omega t. Heat produced across this resistor in time dt formula is dq is equal to, we have I square r into dt. This is the formula. Okay. And heat produced in complete cycle I want. Heat produced in one complete cycle by AC. By AC. How much AC produces the current heat in one complete cycle? We have to do the integration. Integration dq, limits are 0 to t. That is integration 0 to t, limits are dq means we write as I square r dt we write. But from equation 1 we write I as I naught sin omega t. Okay, here this is the dq formula, this one here we wrote, and here we write 0 to t, I we write as I naught sin omega t whole square into r dt we write. And here we can square on both sides, 0 to t, this write as I naught square sin square omega t dt r dt we write. Okay, and the next we write like this, q is equal to, we can write constants outside, this I naught square constant and r will be constant. Okay, this is sin square omega t, and here this r we write outside, I naught square r into integration sin square omega t dt we write. Okay, here we wrote I equal to I naught sin omega t from equation 1 we wrote here like this, right? This is from equation 1 we write. And here integration we want to do in complete cycle, 0 to t is the limits, but we have mathematics formula, right? Then we, according to that we can change it, that is I naught square into r, this we write as integration 0 to t sin square omega t. Okay, we have to multiply with 2 and divide with 2 sin square omega t we will get omega t dt, right? Then here we write like this, q is equal to I naught square r by 2 into integration 0 to t, this we write like this from the mathematics formula. We have the mathematics formula, that is 1 minus cos 2 theta is equal to 2 sin square theta. This is the mathematics formula. 2 sin square theta here it is there, that we write as 1 minus cos 2 theta. 1 minus cos 2 theta, here 2 sin square theta is there, theta is omega t. Theta is omega t, right? 2 theta is omega t we write here like this into dt, right? And here we write like this, q is equal to I naught square r by 2, we can multiply this one 0 to t 1 into dt minus integration 0 to t cos 2 omega t dt. Okay, but q is equal, we will get as I naught square r by 2 into integration dt is t we will get. Okay, limits are 0 to t. Remember this integration is 0. Integration dt is dt, limits are 0 to t. This integration value is 0. Then finally we will get I naught square r by 2 into integration small t, limits we write here capital T, minus in place of 0 we write, in place of small t lower limit we have substitute Then finally we will get the heat as I naught square by 2 into RT we will get. This is equation 2. Heat produced in complete cycle in time period capital T. Complete cycle means 0 to T. Complete cycle means 0 to T seconds. Here we got this much heat. But heat produced by RMS current we write like this, equivalent. Actually in the DC circuit heat produced formula is I square RT is there. If you want to take the equivalent current this further. Equivalent current to AC we take as IRMS. Then heat produced by RMS current. We can take heat produced by RMS current. Heat produced by RMS current we take as Q is equal to IRMS square into RT we write. Okay. You compare these equations. Compare equation 2 and 3. Compare equation 2 and equation 3. If you compare, then what you will get? Here Q is there. IRMS square is I naught square by 2. From this we will get IRMS formula. What you will get the IRMS formula? IRMS we will get is I naught by root 2. This is the formula for the RMS current. This is the formula for the RMS current. This is the formula for the RMS current. If you want the RMS voltage, okay, if you want the RMS voltage, you like take this. RMS voltage, we write as like this. Vrms is equal to V naught by root 2. Vrms is equal to V naught by root 2 we have to write. Okay. What is I naught here? I naught is the peak value of current. I naught peak value of current. Okay. Right. Take the screenshot and note it. Here we got RMS current. Note some important points I am going to give. Okay. RMS current formula is RMS current in AC. Formula is IRMS is equal to, we got as I naught by root 2. RMS voltage we got as Vrms is equal to V naught by root 2. Very important formulas this one. Okay, and here the one more point I am going to give, that is AC current, AC ammeter measures RMS current. Okay, for example here AC current passes through this resistor. How much AC current passes? AC current means current value is varies with the time. How much current it can measures? It will measures the RMS current. Okay, AC current is varies with the time. For every instant of time the current value is changes. But how much current it can measures? If AC current passes through certain wire, then if you connect the AC ammeter, then it can measures the RMS current. AC ammeter measures RMS current. If you connect the AC voltmeter, right? AC voltmeter if you want to connect, then what it will measures? AC voltmeter measures RMS voltage. Okay, and now for example the DC equivalent current, if you want the equivalent to the DC current, AC equivalent to DC, the RMS current value is equal to DC current. And for example like this they gave, that is this is AC source voltage is 220 volts. Okay, in this it supplies some current at any instant of time. For example this current supplies some current I 2 amperes if it supplies the 5 amperes current. Okay, if it supplies the 5 amperes current, 220 volts comma 5 amperes I see, then this is, they gave like this AC source can supplies. Then what we will take this current, for example this is the AC source, they gave like this 220 volts, right? Then this is some resistor, and this is some inductor, and this is some capacitor, right? This is the AC source, and in this some current is passing, that is 5 amperes. Here they gave 220 volts means that is RMS voltage. Okay, from figure we write like this, what they gave in this, right? The voltage is Vrms, AC source voltage is Vrms, okay, and AC current is Irms. They gave the current here, this is AC current value is varies, but here gave some 5 amperes, that means that is RMS current. Okay, right. And the next let us go for the inductive and capacitive reactance. What is inductive reactance? Inductive reactance. This is the resistance of inductor for the flow of AC. This is inductor, resistance of inductor for the flow of AC is called as inductive reactance.